Hello. So today we are going to be adding and subtracting in scientific notation, but I wanted to do a little bit of a review first. Dividing, and then a word problem, how many times longer. So the dividing, remember you divide the numbers. So one way to do that is take the decimal out. 16 divided by 4 is 4, but because there is a decimal point, we have to have a decimal point in the answer. And then we do the powers of 10. When you divide powers of 10, you subtract the exponents. So times 10, 8 minus 4 is 4. And then we have to check, is it in scientific notation? No. So we have to move one place to make it bigger. So since we're making the decimal part bigger, we have to make the exponent smaller. So 4 times 10 to the third. All right, word problems. Remember, when you're trying to figure out what to do, use easy numbers. So just ignore, for right now, the scientific part of it, and just look at 8 and 4. How many times longer is 8 than 4? It's 2 times longer, and we got that by doing 8 divided by 4. So that's what we're going to do with the scientific notation. 8 times 10 to the 6th over 4 times 10 squared. 8 divided by 4 is 2. 10 to the 6th divided by 10 to the second. If you're dividing powers at the same base, you subtract. 6 minus 2 is 4. And this is between 1 and 10, so this is our answer. It is 2 times 10 to the 4th times longer. And then with these types of problems, it's easier to see if we put it into standard form. We have to move that decimal over 4 places. So it is 20,000 times longer. Okay, again, we are adding and subtracting numbers in scientific notation. And it's a little bit different because you have to know how to add and subtract decimals versus multiply and divide. There's also something special about the power of 10 that we need to pay attention to. All right, a quick review, and I won't do all of these, but when you're adding decimals, you need to make sure that the decimals are lined up. So 2.34 plus 4.5, we line up the decimals, and if the numbers don't match, you put a 0 as a placeholder. So 4 plus 0 is 4, 3 plus 5 is 8, carry down the decimal, 2 plus 4 is 6. With subtraction, it's the same thing. You line up that decimal, 6.78. We're going to line up the decimal, so 2.34, and then subtract like normal. 8 minus 4 is 4, 7 minus 3 is 4. Bring down that decimal, 6 minus 2 is 4. So I know this looks a little different than your notes. Because I have yours as in a flow chart, but I'll try to explain. So adding and subtracting. You have to look at some questions and follow, depending on if it's a yes or no, follow a different order. So do the powers of 10 have the same exponents? So that's the first thing you have to look at. So you're going to come over to the problem, and do they have the same exponents? 2 and 2. They do. That means these are alike. They're alike. So we can just follow on the flow chart. If yes, just add or subtract the decimals and keep the powers the same. So you're just going to add or subtract, and then the power of 10, you're just going to keep it the same. So what that looks like is, I'm going to just move this underneath. So 3.23 times 10 squared. And we're adding. We are going to keep the power of 10 the same. It's like it's your variable. If you had 3x plus 2x, you would add the numbers, and what this means is 3 times x plus 2 times x. You add the numbers, and you keep that variable the same. That's exactly what you're doing with scientific notation. You're keeping that power of 10, or the variable part, the same. But you add the coefficients. So 5 plus 3 is 8, 4 plus 2 is 6, carry down the decimal, 8 plus 3 is 11. And then you have to make sure that it's in scientific notation. This one is not. We have to make the decimal one place smaller, so we have to make my exponent 1 bigger. So my answer is 1.168 times 10 to the third. Alright, this one is a little trickier. Now we're going to follow a different path on the flow chart. Do the powers of 10 have the same exponent? Here's a 5, here's a 6. So no. So now you follow the flow chart side that has a no. If no, you need to rewrite them so they are the same. That's using the skills that you learned. If you make the decimal smaller, the exponent has to get bigger. If you make the decimal bigger, the exponent has to get smaller. That idea. So you're going to change, a hint is to change the lesser one to make the subtraction easier. So we're going to go to the one that has the lowest exponent, in this case here. We have to get it to 6. So that means I have to add 1 to the 5. And because I'm adding 1, so I'm making this 1 bigger, I have to make the decimal 1 smaller. So I'm going to change it to this. And then you're just going to add like normal. So we're going to rewrite this. I'm going to rewrite the decimal part down here. I know that it is going to be, my answer is going to be times 10 to the 6th. So I'm going to just rewrite 2.45.
So now you're going to add 2.45 plus 0.323 plus 0.323, add in the 0. 3 plus 0 is 3, 5 plus 2 is 7, 4 plus 3 is 7, carry down the decimal, 2 plus 0 is 2. So now you have this lonely x times 10 to the 6th. You have to put over here 2.773 times x to the 10th times 10 to the 6th. And it is in scientific notation. So now we are going to do an example. So you're going to, as you can see, the 10 to the 6th, there's 10 to the 6th and 10 to the 4th. 4 is smaller, so you're going to have to add 2 and make this decimal smaller by 2. Add the decimal point in. Now you're going to set it up as 7.45 times 10 to the 6th minus 0.0223 times 10 to the 6th. Now you have to do some subtraction. So 7.45 minus 0.0223. So now you're going to carry, this will become a 4 and a 10. Now the 0 has to have more value than 3. So this will become a 9. This will become a 10. 10 minus 3 is 7. 9 minus 2 is 7. 4 minus 2 is 2. 4 minus 0 is 4. Add the decimal, and 7 minus 0 is 7. So now we have 7.4277 times 10 to the 6th. And as you can see, this is in scientific notation already, so this is the complete answer. So now we are going to do another example. As you can tell, that there's -1 and 2, so -1 is smaller, so you have to add 3 to make it a 2, and then move this over 3 times, so 0, 0. Now you are going to set up as 6.326 times 10 squared minus 0.00123 times 10 squared. Now you're going to do some subtraction. 6.326 minus 0.00123, add in your zeros. Now 6 will become a 5. This 0 will become a 10, and then a 9, and this will become a 10. 10 minus 3 is 7, 9 minus 2 is 7, 5 minus 1 is 4, 2 minus 0 is 2, 3 minus 0 is 3, carry down the decimal, 6 minus 0 is 6. So now you have 6.32477 times 10 squared. And as you can see, this is in scientific notation, so that is the end of the problem. That's all you have to do.